Okay. Alright. Looks like this is working now. Hopefully I can get a video. So, fractions, decimals, and percents part 2. Part 2. Alright. We're just going to look at a couple new things today. One is, if I have like a fraction or a decimal that has a whole number attached to it, how do I convert this? How do I convert this? Like this is a decimal, so how do I convert that into a fraction? We sort of talked about this yesterday. A little bit, right? It's the same process. If I have two numbers to the right of my decimal, I just write this whole number over 100, because this is the hundredths place. Or I could think of it as two numbers, so 2 zeros in my denominator. And then I would have to reduce it, right? I could divide both of these. I could divide them both by 4. Right? 4 goes into 25, like 64 times. I mean, into 25 6 times, right? And then into 16 4 times, and then it goes into 100. So it doesn't really affect it that much going this way, right? But what if I had something like this? 2 and 3/5. How do I convert that into a decimal? The key step here is this 2 is just going to go right before the decimal. So the 2 is just the number that's before the decimal. Then the fraction, how do I convert a fraction to a decimal? Convert a fraction to a decimal. No idea. 3/5. Dude. Back in your notes from yesterday. Right. You can say.
You divide.
Divide, right? 3 divided by 5. 3 divided by 5 doesn't go in, but 5 goes into 36 times. So we've got 2, and then I'm just going to put this 0.6 right here next to that. Right, so I can kind of do this in 2 steps. The number, and then the fraction. The other thing that I didn't really talk about yesterday in the lecture was repeating decimals. And there is a way to convert these. Say I had something like this, 0.11111. And the 1 is the repeating decimal. I have no idea what 0.11111 is. And my normal method, right, of like putting it into a fraction and counting up doesn't work because this goes on forever. So I'd have infinite zeros. Do you know how to do it? You're right, we bring this over. So what we're going to do here is actually turn this into an algebraic problem. 0.1 repeating, we're going to say that that's equal to x. Because we don't know what it equals as a fraction. So we're going to call it x. Now, the most common thing to do is to multiply this x times 10. And if I multiply the x times 10, I also have to multiply this side of the equation times 10. So that would be just simply moving the decimal place one space over. And now we're going to do something that we've never done before. We're going to take this equation and we're going to subtract this equation from it. So I'm going to actually write this first equation right below my second equation. And I'm actually going to subtract the entire equation. I'm going to subtract this from this side And I'm going to subtract this from this side. So now I'm getting rid of that repeating decimal. And 10x minus x is 9x. So if I wanted to solve for x here, what would I do to solve for x? Divide by 9. And so I found out that x is equal to 1 divided by 9, or 1/9. So I actually wrote that as a fraction using algebra. And this is really the only way, or the best way, when you have excuse me, when you have repeated decimals.
So you always multiply by 3 times.
Okay. So you picked up on the step that can change. 10 is really common. It's something that's really common to multiply it by. What I actually am doing here is I'm trying to multiply it times something that will allow me to cancel off all the repeating digits. So for example, if I had the number 0.17 and the 7 is repeating, I have two options here. Okay, if I multiply this times 10, I would have 1.7 repeating. So this doesn't exactly line up perfectly, right? Like if I subtracted this from this,
But you can add another 7.
it does repeat, so it would work. I could do it this way. But I could also multiply it times 100. That would be 100x. And then I could subtract the 10x from the 100x. And those would line up perfectly. So I'm kind of like experimenting in a way to figure out how I'm going to combine my equations to get rid of all these repeating decimals. If 100x equals 17.777 and 10x equals 1.777, I could subtract this from this, and all these 7s would cancel out, and I would have 16 equals 90x, or x equals 16 over 90, or 8 over 45. So this time I multiplied it times 10 and 100 to get it to cancel out. And sometimes you're going to have to multiply it times 100 in order to get the decimals to line up. Our goal is to multiply this and get our decimals to line up so that they cancel out. Any questions? So,